email, or we'll be. And
hello, everybody, and welcome to this week's Future in Space Hangout. My name is Tony Darnell. I work at DeepAstronomy.space, and today we are going to be looking at NASA's latest mission to Mars. The Mars InSight lander is scheduled to go off of our launch very soon, and we're going to talk with members of the team to learn about some of about the spacecraft itself, when we're going to be launching it, how, when, where, and what it's going to do when it gets to Mars. So there's a little bit of irony here in this Hangout, because Harley and I have been reworking some of the Hangout structure, and we've been doing this in coordination with the American Astronautical Society, who is the sponsor and the provider of these Hangouts to you. And we decided that we were going to get rid of the Footsteps to Mars series because there really wasn't a whole lot to do about Mars on a regular basis, we felt, on a monthly basis that we felt. So we decided we would just call the first Thursday of the month and the third Thursday in the month, which is the month we do these, all just Future in Space. It just so happens that the first one today is about Mars. Okay, so
excuse us.
Right. So anyway, but I did want to let you know that Footsteps to Mars is no more. We're all doing Future in Space now, and Future in Space. I'm going to have Harley introduce the Hangout here in just a moment. Is based on the future and primarily human space flight, as well as space astronomy, things like that, but with an astronautical emphasis, engineering emphasis, because the Astronautical Society is very interested in those things. So here we are. I want to invite you guys to chat with us. I'm on the live stream, the live chat on YouTube, and John Suffolk's there, and a couple of other people are ready to go. I'm looking at that, so ask our guests, build up some questions for our guests. I'm also on our Discord server for chatting as well. If you don't know what Discord is, it's you can go, if you go to deepastronomy.space/live, you'll see a link to our Discord chat. You can participate right there. So anyway, let me go ahead and bring up everybody. Here we go. Down below, we have our guests today, two of which are from JPL, one of which is from NASA Goddard, our co-host. Let me start with him. Dr. Harley Thronson's in the bottom panel there. Hi, Harley.
Hi, hello, good afternoon.
Hey, welcome. And how about giving, you want to give a quick introduction into our Hangout series and what we're doing here?
Yeah, exactly. Although actually, Tony, you said about 90% of it.
Yeah, I did say a lot of it, but yeah.
Yeah, you did. I think the biggest point we want to make is our thanks to the American Astronautical Society, which is supporting this. They have a broad range of interests in space exploration, technology, science, launch vehicles, all kind of technology and engineering. So we will be covering quite a landscape over the coming months, and we hope coming years. And it is ironic that we decided to wrap up the Footsteps to Mars into a general exploration discussion of all kinds of space sciences on the eve of the launch of this really terrific Mars mission, the InSight mission. Just about I think it's scheduled for about almost exactly a month from now, is it not? This is for Emily and Johnny, who I'll be introducing in just a moment, our guests today. So, in fact, actually, let's go to them. And we're going to ask them in turn. I don't know which one of you will be like to lead off, Emily or Johnny, two key participants in the InSight mission. And in fact, actually, why don't we just go to them now? Which one of you, Johnny or Emily, would you like to take the lead on this? Introduce us to the mission, to yourselves and to the mission. Emily, how about this? You're up on my screen now. Emily, tell us a little bit about yourself professionally, and then introduce us to the InSight mission. Emily.
Hi, I'm Emily Manor-Chapman. I'm an engineer at NASA's Jet Propulsion Laboratory, And on the InSight mission, I'm a member of the Payload Systems Engineering team. So my responsibility is to work with the instruments that we're sending on InSight to Mars. And primarily, I work with the Auxiliary Payload Sensor Suite, or APSS for short. That's basically our weather station instrument. It's going to tell us about the weather on Mars. And so I'm responsible for taking that instrument through our system level testing and getting it ready for operations on the surface of Mars. So to just give you, oh, sorry, go ahead.
No, go
well,
ahead.
okay. So yeah, the reason I got quiet there was I was listening to, I was seeing in the chat, they're saying that my voice is low, sound issues again. So I was listening to everybody, and quite frankly, guys, they sound fine to me. Now, maybe I'm too low. I don't know. But I will talk louder to make sure it goes through. Don't know what else I can do right now, but we're going to keep going with the sound the way it is. And that's why I got real quiet there for a minute. So thank you, Emily, for introducing the mission. And I just wanted to point out, though, before we get too far on, we've got 29 days, 15 hours, 57 minutes, and 44, 43, 42, 41, 40 seconds left for launch. And it's going to go out. And I'm trying not to hold this against NASA. I really am. But I'm trying. They're launching this time from the Vandenberg Air Force Base, and not the Kennedy Space Center, not the place where rockets were meant to be launched from. I just wanted to put that out there because you guys are, I don't know what you're doing. But I wish you luck anyway. I do, and I'm not going to hold it against you. But anyway, it is going to be, it's a different launch. I won't be seeing it live, but I will be watching it live on the stream that as it comes through. So May 5th, 2018 is the scheduled target date for the Mars InSight mission. And Emily gave us a great insight, great introduction to what the mission will be doing. Johnny, Jonathan or Johnny? Which one?
Johnny's fine.
All right, Johnny. So tell us a little bit about what you're doing on the mission, and then I'm going to ask you guys a bunch of specifics about the mission itself.
Okay. So I'm on the InSight team. I'm the lead payload systems engineer. So I oversee all of the requirements, testing, development of all the payloads, or scientific instruments that are flying on InSight. And we have quite a few instruments. I don't know if you want to walk through them.
Well, I do, in fact. But let's go ahead. Let's take a little. Let me put this up real quick. Where did it go? There it is. Let me put up your little slideshow because you got a really good slide thing here. Let me get rid of your name because we don't need to see that right now. Okay. So here is here's some slides that talk about the overview and the status of the InSight mission. There's a nice picture of it there. Quick summary of when it's going to be launching later in a couple months. It's going to be landing November 26th, 2018. It's got a fast Type 1 trajectory, 6.5-month cruise to Mars. What does that mean?
So that means this is actually much faster than our typical launches from Earth to Mars. My past experience has been 9 to 12 months, so this is really fast.
So 6.5 months is going to take to get to Mars.
Yep.
And then when you get there, you're going to spend 2 months deploying it?
Yeah, it takes about 2 months. And by deploying, what that means is we have a couple of scientific instruments that sit on our deck, and we use the robotic arm to place them onto the surface.
Oh, okay. And then, of course, you'll be there. It looks like you'll be there 2 Earth years, 1 Mars year. Yep. Science operations on the surface, repetitive operations, and of course you're nominally scheduled to end November 24th, 2020. So everything looks nicely planned. Oh yeah, I like this. So thanks for this. This was really nice touch, Johnny.
Yeah, no problem.
No alligators, and you're gonna have otters instead. Otters. There's otters in Florida, and do you know that they have been actually attacking people down here? I'm not kidding. They have been. There have been otter attacks here in Florida, and they're big. They're like the size of a dog. Okay, so here is where you're going. This is a quick little schematic. This is that Type 1 trajectory you were talking about, right?
Yep.
And see if I can see there's my mouse. So here is Earth at launch. You're going to basically, doesn't these kind of use Earth to push spacecraft a little bit?
Yeah, we do one orbit around Earth before doing a final boost to go to Mars.
Okay. And so then it kind of throws it out there, and then you're going to get there as Earth is well past Mars as well. So that's pretty cool. So that's the deployment phase. I don't want to go into a lot of the bullet points, but here's the spacecraft itself. You want to talk a little bit, Emily, about some of these instruments?
Sure. So what you're seeing here is the graphic of the InSight lander, and what we've pointed out here are the various parts of the lander. So let's start with the two instruments that we're going to deploy. So on the left side of the picture, you'll see the seismometer instrument. So the seismometer instrument is similar to seismometers that we use here on Earth to measure earthquakes, but we're taking it to Mars so we can measure Marsquakes. And then sitting on top of the seismometer, you can't see the seismometer itself in that graphic. On top is a windshield. We put that around the seismometer to protect it from winds in the environment of Mars. Because the seismometer is so sensitive, we wanted to give it that extra covering
so this
from
thing,
the outside element.
You're talking about this thing right here?
Yes, the white thing that you see is the cover that goes over the seismometer.
Ah, okay. And the seismometer, is this what you mean, Johnny, when you said this is the robot arm and you're going to actually, because it looks like it's been picked up in place there, or at least it fell off or something. But
Yeah, so before deployment, it's sitting on the deck, it's bolted down to the deck, and we fire some Franger bolts, which releases it, and then the arm picks it up, places it on deck, and it has a tether that spools out from the deck. And that's what allows power and data to come across.
These are tethers here. They look like ribbon cables that come out. Okay, seismometers measure what?
The motion of the ground, pretty much.
Okay, so like little earthquakes and stuff like that, right? Okay.
Well,
Yeah.
Marsquakes.
Mars. Oh, that's right. Marsquakes. Right. Sorry. Yeah, Marsquakes. Now, one thing that I'm a little curious about is that I thought Mars, geologically speaking, wasn't very active. I mean, it doesn't have like a magnetic field because it doesn't have a very powerful magneto down in the core of it. Is there tectonic activity going on Mars that, well, or maybe you don't know, and that's why you're sending this out, right?
So we actually know there is no tectonic activity. So in that sense, it's different from Earth, and why this helps us find out about the past life of Earth. Because of the lack of tectonic activity, you don't have in the mantle things getting mixed around like you do on Earth. As everything bubbles up and cools down, falls down. Everything's kind of the same way it was since Mars formed.
So it never had tectonic activity.
Yeah,
wow.
Due to its size.
Oh, I didn't know that. Yeah, because the Earth, they say, is it's very active geologically, such that it actually replaces the entire crust of the Earth every so many 100 million. I don't know how many millions of years, but it's a long time. It completely replaces the crust after a while because it's all, like you said, boiling up and then going out over the sides and then coming back down again. So it's a very active surface area. But Mars never did that, huh?
Yeah.
Okay.
So any quakes we see is actually mostly due to cooling of Mars, and it contracting slightly, and that causes vibrations to ripple up throughout.
Okay.
Has there ever been a seismometer on Mars on any of the earlier missions?
Yes, Viking carried seismometers, but they stayed on Viking. We didn't place them onto the surface. So, and they were less sensitive than the one we're carrying on InSight. So InSight will be the first time we've actually deployed a seismometer onto the surface of Mars.
Man, Viking did everything, didn't it? It's like, wow, they put everything on Viking when they launched.
Yeah, that was the 70s. The giants walked the Earth, and
giants walked the Earth. Blah blah blah. Why do I sense some resentment there, Harley? It's like what? yeah. They did it all.
I'm just a simple astronomer. So one of the interesting, and apologies, I had to step away a few minutes ago. So you may have already mentioned this, and once again, either Emily or Johnny, one of the interesting presentations that I heard yesterday at a meeting about InSight was the testing that was calibration testing, whatever it is, in what was it, a German mine, presumably some year or so ago, to demonstrate the almost unbelievable sensitivity of the seismometers on the InSight mission. Do you know, were you all following that, or were an active part of that activity?
We're definitely following it. There's others on the project that were actively involved. And this was at the Black Forest Observatory in Germany. And basically we have a similar seismometer to what we're sending to Mars, and it's one of the quietest places on Earth seismically. So it really lets us see how our design performs in a really low noise environment, which is hard to get anywhere else on Earth.
I gathered by implication, and then I ended up looking it up on the web, that this is a site that the German government, or maybe the Bavarian government or somebody, offers because it's such a seismically quiet environment, like the InSight seismometer or other seismometers that really need to be extremely sensitive, are taken there and tested or demonstrated that they really can perform. So it will be ready to go when it goes to Mars, and you all will know how well it's expected to perform.
Yep.
Yeah, I have the slide up that you guys provided on this. So this is the Black Forest Observatory they used for the testing. And so if it's such a low noise area, such a low geologically area, you wonder why they didn't build LIGO there. That'd been kind of cool.
Yeah. Yeah. Do you know how big LIGO is?
Yeah, that's true. Okay.
2 arms, also 2 arms. Any case, I'm sorry. So,
well, I wanted to show this just because this is also showing after it's all been packed up, and this is how you move it around. I'm starting to learn, based on what I've learned about JWST, is that they build these specialized crates for almost every mission. It looks like the JWST had a crazy one that fit into a Galaxy C5, although this looks like a C5 also.
This is C-17.
Oh, C-17? Okay. And here it is getting loaded in and shipped to Vandenberg after testing was complete. So it's now at Vandenberg, I think, right? And this is, here we are getting ready. What are we doing here?
So a number of things going on here. So the top left picture is when it was getting uncrated. So it was shipped basically in the full configuration, the flight-like configuration. The bottom left picture shows you kind of the underside of it. So those 3 bronze colored discs you see are actually the landing legs that will deploy. And you're looking at the radar staring right at you. The top right is what's called the spin test. So basically you stick it on a platform and spin it around, and that lets you know that everything's balanced on it. And if anything's not balanced, you can add some mass to make sure that everything is balanced on it.
Is that because it's spun up after launch?
So we're actually not a spinner spacecraft.
Oh.
We're 3-axis controlled. We still want everything to be balanced because all the propulsion system is assuming that you have a balanced spacecraft.
Oh, okay. But you're still spinning it just cause?
Yeah. So all spinning does is tells you if the spacecraft is balanced or not.
Oh, okay. All right. And then down in the lower left, it says business end. This is the part that faces down toward the surface of the planet?
Yep. So you see the radar is a hexagonal thing looking at you, and then the 3 bronze-colored discs are the landing legs that deploy.
Yeah.
And the heat shield would go on top of there.
Okay. All right. That'll be to protect it from the entry. And here it is getting stacked and ready to go. It's quite different. I don't know. It's kind of, it looks a bit amateuristic to me out there in Vandenberg. I don't know. I guess that's the way they got to do it.
Lighten up about that.
Lighten up about that. You're going to make them mad.
I understand from once again, from the presentation that was made yesterday about InSight, is that in the lower right or the right-hand side, you see the launch vehicle being carried out, I guess, to being prepped. And behind it is that the that's the passenger rail line there. So although the passenger trains don't go through Vandenberg during the launch sequence, they would potentially get a terrific view. And on the InSight website, they have information about where folks, if they want to see from a safe location, of course, if they want to see the launch, information on where they can go and watch this launch. So folks in the audience who are out in Southern California or will be in Southern California ought to take a look at the website. It's very accessible.
Yeah, here is this it, Harley? I think this is it. This is where I got the countdown from. Mission overview. More about launch. So let's see what happens if we click here.
There's watch in person on the right-hand side there.
Huh?
In fact, while you're trying to find there, move over one more, and then and Emily and Johnny, are you yourselves going to be out in the neighborhood to watch it?
Yes, we're both planning to go up to the Vandenberg area to be able to watch the launch. But for people who aren't able to make it up to the Vandenberg area, if you're in SoCal, if it's a clear day, it will probably be visible anywhere from Santa Maria in the north to San Diego in the south. So it's a really great opportunity if it's a clear morning for all of Southern California to be able to see this launch.
And we just saw the time. Was it 6 a.m. ish, something like that?
It's 4 a.m. Pacific time.
Oh, well, 7 a.m. here on the East Coast. So I'll be up to watch it.
Yeah, it says 4:05 a.m.
Yeah, very exciting. That should be actually just beautiful. Sun will not be up, if I recollect, but that'll be a terrific. If it's clear, that'll be a terrific view.
I tease Vandenberg. Definitely go and check that out. I'm sure it'll be an amazing launch. And
so tell me, why is it being launched from Vandenberg rather than from, say, Kennedy? And Tony, keep your mouth shut about this. Why from Vandenberg?
Okay.
Otherwise, I did not want to give Tony another opening on Vandenberg versus Kennedy. So once again, Emily or Johnny, could you explain? I do not know. I'm not being coy.
So it's due to the launch vehicle we're using. We're launching on an Atlas V, and then the mass of InSight. The Atlas V was capable enough that we could launch from Vandenberg, and we had enough throw mass with the rocket, given the smaller size of InSight, that we could launch from Vandenberg and still have an efficient trip out to Mars.
So it's, that's still, though, so interesting. But would you have lost some of that efficiency if you had launched out of Kennedy?
No, with the Atlas V, we were capable of launching from either site. And Kennedy does tend to be more busy, have more launches, so that was also a factor in terms of looking at when we were launching and what was the manifest at each launch site.
I see.
That's actually true, yeah. With Blue Origin and stuff, building a new facility there, I guess they're all fighting for launch space and times now. It's getting to be quite competitive. And they're building things elsewhere, too. And I think in Texas they're building one, and in other places along the West Coast. So, yeah, we're starting to, I think we're hitting the era of not only commercial spaceflight, really using a lot of resources and infrastructure. I think we're finally going to expand out in other parts of the country. So I think even Louisiana wanted to get in on it at one point. I can't remember. But yeah, a lot of people are doing that. So, okay. So Vandenberg, 7 a.m. Eastern time, way dark 30 Pacific time. Let's talk about where you're going to land. So here is a site that you're planning to land called Western Elysium Planitia. Why do you think that's, why was that site picked for any scientific, obviously it was, so I'm leading on here, as a scientific basis. What was the reason for landing here?
So what we were looking for was a site that was flat and very boring, actually.
Really? You want to, oh, I see. You mean boring feature? Yeah,
boring feature-wise.
Topology-wise.
Because for what we're trying to do, we're looking at the inside of the planet, so there's no mission objectives are looking at the outside of the planet, so we're not looking at interesting rocks or formations or anything. So the safest place to land the area that we'd have the most likely have the most success in successfully deploying our payloads on something that's flat and even, which is really important, was in this area.
And the and again, getting back to, in this case, boring is important. You don't want to land on rocks, boulders. You don't want to land on a high incline.
Right.
You know, you wouldn't tip over unless, you know, obviously not. But you do want it. Of course, it's, horizontal, flat, because nothing that is of that most people think of interesting on Mars could be not of much use to you all and could in fact be dangerous.
Yeah.
Overstated a bit, but yes. Yeah. Emily?
And also, like we talked about, we're putting instruments on the ground. So that's another reason why we want a featureless area, is so that we have in front of the lander a good selection area for where we can select to put our seismometer and our other instruments, the heat probe, on the ground. We want a flat area for them.
Mm-hmm. Mm-hmm.
Okay.
Interesting.
I just added the little bit where it shows where Curiosity is. You're just a little bit north of there, it looks like. So how far away is it from Curiosity? Do we know? Roughly, if it lands exactly there?
Yeah, I'm not sure of the exact distance, but we will be competing with orbiter time. For the orbiters going around Mars to relay data with Curiosity.
Oh, that's an interesting point.
We have to share nicely.
That's right. There's like a bandwidth issue, isn't there, with things on Mars trying to communicate with things on Earth, because we rely on orbiters and currently in orbit around Mars to get the signals from these landers and rovers out, right?
Yep.
Yeah. So.
Yeah, with the Spirit and Opportunity, when they were there, when Curiosity landed, it wasn't such an issue since they were on different sides of Mars. But with where InSight's landing, it's much more of an issue. So we'll share nicely.
Yeah, play nice out there.
Yeah. So once again, so I had to get offline to handle something 10, 15 minutes ago. Other instruments on, did you guys have a chance yet to cover the other instruments on InSight?
We haven't yet. Yeah,
let's do it. I thought one of the interesting, and I'm using the wrong term, but there's a heat probe. Is that not, I said I probably used the wrong term. And would either of you like to discuss what that one is about?
Yeah, I can take that one, Johnny, if you want.
Sure.
Yeah, so the heat probe, what it is, it's another instrument we're going to place on the surface, and it contains it's a probe that will go down into the surface of Mars. So it's a self-hammering probe. Will go down about 16 feet underneath the surface, and it will measure the temperature throughout that depth. So if we can go back to that picture that called out all the different components of the lander.
I'm heading there right now. Okay.
It was slide 3.
Yep. Let me pull it up. There you go.
So if you look to the lower right, that black box that's sitting on the surface, that's the heat probe. And you can actually see in the illustration the probe having hammered down into the surface of Mars. So trailing behind that probe is a tether or a cable. And all along that, we have temperature probes, and they will read the temperature throughout the surface. And then just within that 16 feet, reading the temperature from there helps us learn about the temperature throughout the inner areas of Mars.
There's what's the label on there that says twins? What does that do?
Twins is the temperature and wind sensor. That's part of the APSS that I mentioned. So it will help us measure temperature and winds throughout the day.
Okay. That's a great acronym. Okay. Okay, so we are getting some good questions here, and I don't want to let too much time. When the questions start coming in, I want to give these guys more of a chance to have a say in the Hangouts. So I'm going to go with one that I saw from Galaxia. Hi, Galaxia. Based on which phenomena or lack thereof do you know Mars has never had plate tectonics in its history? This is going back to when we were saying it never had it. So how do you know?
We can tell by the size of the planet. So I guess it's theoretical, but we know looking at Earth, and that depending on the size of the planet determines how much activity there is. So our estimates are that something the size of Mars wouldn't have tectonic activity.
So this graphic here, does it kind of show an accretion, the way Mars accreted or came together? Is that what this is showing?
Yeah,
so
the artist. Sorry,
yeah,
go ahead, Johnny.
So all the rocky planets started off the same. There's an accretion of various materials, but depending on the size, kind of determined the ultimate path that it followed.
Okay. And I understand, and this is from my Sky and Tel. It is this. I hope this is correct. Because my understanding is that since Mars, and it applies to the Moon too, but the Moon had so far as we know, had a very much different origin. So far as Mars goes, so small, it cooled off much faster than the Earth did. The lithosphere, is that the right term? The solid outer parts of Mars solidified much more quickly and much more thick than the Earth. So it never had the plates moving, or maybe it did for a tiny part of time. It never had the big plates that the Earth does moving around because it's solid. The outer parts of Mars are just solidified so quickly.
So does that mean the crust is thicker, Harley?
Yeah.
Than Earth?
Yeah.
Okay.
And became, I said, the crust became solidified so quickly, so thick that you never had the plates floating around on the top of a molten core. Plus, you don't see you don't observe the plates or anything like plates on Mars.
Yeah. Okay. Well, Larry Keese's
comment. Nothing like the Earth.
Right. That's.
So Johnny and Emily, did I get that? It was a bit awkward, but did I get it about right? Yes.
Emily's like, yeah, sounds good to me. All right. Larry Keys is commenting on Discord. Don't diss the Viking team. A good friend did the Viking lander software that worked perfectly. The spinning is for the launch vehicle dynamics. Okay. Well, I wasn't dissing the Viking team. I was praising it, saying how great Viking was. But Viking did do everything, right? I mean, it tried to anyway, and it did quite well. I'm not dissing Viking. I thought it was awesome. And he's also commenting that he will be able to see the launch from home, which I guess he's down in Southern California. So that's great, Larry. I'm glad you'll be able to see it. Okay. So this, there was another question here. Where'd it go? Hans Milling is asking, how can you measure if the shaking is from a meteor impact or from inside the planet? That's a good point, because you'll be able to sense those, right? If something hits Mars, you'll be able to feel it. How can you tell the difference between that and something from inside the planet?
Emily, do you want to take this, or?
I'll let you take this one. You probably answer better than I can.
So it all has to do with the types of waves that are generated. With something that comes from the interior, you basically get a certain set of waves that will hit the seismometer at a point in time, versus a meteorite impact, you'll kind of get a dispersion of waves. Some that go through the center of the planet, some that kind of go around the circumference of the planet, and they arrive at different times. So using that, you can see what caused the shaking, basically.
And it'll be a characteristic difference, wouldn't it? I mean, in the patterns of the seismic recording, wouldn't it? I mean, you'd be able to tell if something hit, it'd be more like almost like a gravitational wave, right? I mean, you could sense it, and then it would have an amplitude that maybe died down over time. That would be from a certain direction, perhaps. Okay, well, Achilles 308. Will InSight have a true color camera? They love pictures. People love pictures.
It is a color camera. It's called Bayer filter camera. So basically, it was a black and white camera. It's the same camera that we've had on previous missions that we've used for navigation engineering, and we added a color filter to it, basically. So it will have to be adjusted on Earth. We have a color calibration target on board that we take a picture of, and using that we can basically we have to post-process to get what the color looks like.
Okay. So yes, there will be some pictures. Has there Achilles 308 again? Why has there never been a microscope landed on Mars? When can one be launched? A microscope?
Oh wait, the MSL has a high magnification. I don't know if you call it a microscope, but does an MSL have a high magnification optic?
Yeah. So
on the end of its arm has a an imager, and also the rover's Spirit and Opportunity had one too.
So there you go.
But it's not microscopic, I guess. It's just high.
Yeah, I guess I guess maybe it's defined by its magnification, I guess, or how close up it can get. But I've seen, even when Spirit and Opportunity were out, some really high resolution close up images of a lot of rocks and geologic little features inside the rocks and things like that. So they've had some pretty high resolution stuff there, Achilles. Let's see. What experiments are on board for detection? This is from Alexander Rangers. What experiments are on board for detection of Martian life? Anything?
So we don't have anything to detect life. This is a completely geological mission. We leave it to the rovers to go life hunting.
Go life hunting.
Although I like to pause right here, because that was, of course, a good question, and I suspect that Emily and Johnny and the whole InSight team get that question all the time. So I'm going to vary it a little bit. And I don't know the answer to it, so it might be a useful discussion. The question of life on Mars, extant or in the past, is a huge question, obviously. So it's not certain. We know that InSight will not search for life, but are the plausible scientific results from InSight, will they have bearing on the hunt for life, the search for life on Mars?
That's a great question.
I don't know the answer, but I think it's an interesting question.
Yeah, it's really hard to say.
You could imagine in an extremis, the imager might. So if it was to see a fossil skull, of course, that would be implausible, but it would be some. But it is an interesting question, and I don't know the answer, so it'd be somewhat speculative on my part. I was wondering if Emily or Johnny had a thought on it.
I don't know how our discoveries will impact the viability of life ever being there or currently being there.
Mm-hmm.
Alex is going, so set up some last minute experiment. No. Yeah, let's just mess with the mission now that it's all up on the rocket and everything else.
Now, folks should recognize that the geology of Mars is pretty darn fascinating, because you have these trio of terrestrial planets, Venus, Earth, and Mars. Each had a somewhat similar formation history, and each had a vastly different evolution after they were formed. So the geology of Mars, contrasted and compared with that of Earth and Venus, is a fascinating field of study.
Oh, okay.
Yeah, Harley's right. What we learned from InSight in Mars really can be applied to the other rocky planets in our own solar system, and they even have applications to our hunt for exoplanets and looking for rocky exoplanets.
Good point. Yeah, good point.
Okay.
By the way, to throw in a bit of irony, we just had an earthquake here in Los Angeles.
I mean, just
I
now.
thought that shaking was an earthquake. I wasn't sure though.
You mean just now?
Yeah. Enough,
like right now?
Yeah, about 10 minutes ago. I kind of ignored it. Right?
Oh, you guys are pretty hardcore. Wow, you just sat through an earthquake in this hangout and you didn't even mention it?
Sorry.
Oh, wow.
Southern Californians are tough.
You guys are. That's hardcore, guys. I got mad respect for that. That's amazing. Yeah, they just sat through an earthquake. They're like, oh, let's just do the hangout, man. Just whatever. Whatever. Let's just keep doing the hangout.
To be honest, I felt it but couldn't tell, because a lot of times just movement in my building will cause like the blinds in my office to shake. So I seriously just thought someone was like moving furniture around.
That's true. I've worked in places where people walking down the halls make it sound like an earthquake.
Yeah.
So yeah, that's true. Okay. Wow. That's great. Well, I wonder if Mars InSight picked it up. Okay. Here's a good question from Oh, wait, let me get to vibes first. Vibes spelled with a 3, vibe threes. How deep does the heat flow probe go into the soil? I think you answered that, but maybe we'll just mention it again. And is there any fail-safe on board in case the ground does not give way? The probe is stationary, so you can't try somewhere else. It's a good question. How deep will it go, first of all? You've already said, but say it again. And what if you can't get it to go all the way down?
So it'll go 16 feet down, but I'll let Johnny talk about any fail-safes that it might have.
Okay. So if it goes down and hits a big rock, it cannot go past it, and we have no way of pulling up the tether and moving it or anything. But for a large multitude of like angled rocks or smaller rocks, it could actually go around it, and it has a tilt meter on board, so we know that it did that as it's going down. So we actually know the full path as it's going down into the surface of Mars, where it went.
So you know that before going in?
No, so we know, so we get telemetry as it's hammering down the path that it's following. But before, all we see is what's on the surface, and we really have no idea what's below it.
Okay, talk a little bit about the radar. What's the radar going to? First of all, how does that? Is it just normal high resolution radar pointing down to the ground, and is it going to how far deep will that go?
So the radar is actually for entry, descent, and landing.
Oh, okay. Oh, I see.
How high up we are for the various actions that happen as we're doing EDL.
I see. Good. I was wondering about when you said radar and it was facing down. I thought, well, okay.
In fact, actually, I'd like to ask a question. Oh, I apologize, Emily. Did I interrupt you?
Oh, no, go ahead.
Okay. I wanted to ask one or the other of you, in case I missed it. What is the landing sequence? What all will take place in the landing of InSight? How does it go?
So it's very similar to the Phoenix lander. We're using the same landing system. So we have a cruise stage, and we're inside of it, basically. The lander's inside of it, covered by the heat shield. And at some point, as we start, right before entering the Martian atmosphere, the cruise stage detaches, and we enter like a flying saucer down into Mars. And then eventually the heat shield comes off, lander pops out, and it's we have thrusters on the bottom of the lander that give us controlled descent, and we land I think 5 miles per hour down onto the surface. So it's not like the Curiosity rover, which had a sky crane with the rover hanging down, and it's not like Spirit and Opportunity that had airbags that kind of rolled on the ground for a while. So this is kind of the gentlest way to land possible, along with the sky crane.
Yeah, that sounds like a pretty straightforward way to do it. That Curiosity thing, I don't know how many times any of us could live through that. I mean, that was wow. So okay. Achilles 308's commenting, Zoom photos can't identify fossilized microbes. So okay, you're right about that. So to get super high magnification, I know what you mean by a microscope now. So okay, let's see. Maybe okay.
So here's another. Speaking of life, here's a question for Emily or Johnny, speaking of life, human explorers. I know that our colleague, I'm speaking as a NASA person, our colleagues in the human spaceflight program at NASA have been working increasingly close with the science program, particularly the Mars program, to carry out experiments, place experiments that would be of use to one day, as we prepare one day for sending humans to Mars. Are there any obvious experiments? I think imaging and a lot of the information about wind, micrometeorites, and so on and so forth will be useful. But were there any experiments that were particularly useful for one day sending humans to Mars? Emily or Joanna?
Well, would say none were particularly chosen for that reason. But like the weather station I was talking about that we carried, that will be important because again, it's another data point from the Mars missions we carry because there's similar sensors carried on Curiosity. The future Mars 2020 rover will have similar weather measuring capabilities. So that putting it on InSight, that helps kind of have us just expand that record of being able to measure what the environment is like through our temperature and wind sensor and through the pressure sensor that's part of the APSS instrument.
Right. It doesn't, for example, carry, I think a number of our Mars missions have carried, for example, cosmic ray detectors. InSight does not.
No.
Right.
Okay, I found the question I was looking for. One plot is asking, has InSight the capability to carry on past its mission date? We talked about it being there for 2 years, Earth years, 1 Martian year. Can it still keep going if it's working, everything going okay? Or you guys, is it a hard cutoff? You're going to turn it off and go home?
We would never turn off a spacecraft that's working. So it's designed for 1 Martian year, but there could be things like accumulation of dust on our solar panels, or various components failing. They don't go past their design lifetimes that would prevent it from going. But the design is so that it lasts at least 1 Martian year, hopefully longer. Great.
Okay, that's a good question. I guess Larry Keys also felt it, the earthquake. He just commented on that. And other people are like, I didn't feel anything. So now they're talking about the earthquake. So
by the way, this is for Emily and for Johnny. It is these kinds of events that allow us to map out where the participants are, where our audience is.
Yeah, that's right. We're spying on you guys.
Folks complain about earthquakes. Folks complain about blizzards. So we can just look at a map of the U.S. and determine where these folks are.
He goes, I guess Hans felt it too. That is a good thump. I didn't feel much in South Bay, looking right at the islands. So there you go. I think that's most of the questions. If you guys have more questions, please let me know. I want to put this up real quick. This is for those of you since you're talking about earthquakes with each other, and a lot of our viewers are already in this area. Here is the slide on the launch viewing. So there's I think this was the URL you were talking about, Harley. That's
it.
Yeah.
And they have a nice little map, a little bit difficult to read, but it's on the website. And they note helpfully that the guest operations will be in Buellton, and those of us who grew up in Southern California and drove from home to college back in the day, famous pea soup Anderson's is there, so you can get.
I love split pea soup.
Yeah, exactly. Also, you should note here the down at the last 2 bullets, the historically this I didn't know this. This was in yesterday's presentation about InSight. The historically they've had an extremely high success rate in conditions being ready for launch during this time of year. The Atlas vehicle has got a high probability of launching the first time. There's also a very high probability of coastal fog, which does not limit the launch. The vehicle can go right through the fog, which could make a really spectacular launch if you're above the fog along the coastal range.
Yeah, as it breaks through, that'll be amazing.
Yeah, so just a note, and again, Emily and Johnny can confirm this. Just a note that the window, the launch window, is about 2 months long. Is that right, guys?
It's 1 month long, so we have opportunities from May 5th to June 8th, and then I believe every day we have about a 2-hour window each day that we could launch within.
So very likely, and I guess the launch window on each day moves slightly through the day.
It moves.
That's correct.
Yeah. So the odds of folks seeing a launch are very high the first day, and of course very high if the odds are against it, it doesn't work out, very high on subsequent days. So this is like, if you live in the area, I'm not making any promises, I can't do that, but at least judging from the statistics that we heard yesterday, this is a good chance to to see it on the very first day.
Okay, there you heard it. You heard it here first, folks. Harley promises it'll go fine. So
I believe I qualified that. Exactly.
In
any case, and then just to remind folks, was it November when it lands?
Yes, November 26th, which is the Monday after the Thanksgiving holiday in the U.S.
Yeah.
And there was something significant that was mentioned that also occurs on that day. Somebody was making some fun at the presentation.
Probably Cyber Monday, so if you're online doing your holiday shopping, also bring up and watch our live stream, because we will have a live stream of our landing and the folks here at JPL who will be monitoring that event as it occurs.
Oh, that'll be awesome.
I believe it's about noon Pacific time, so right in the middle of the day, so it'll be easy for folks to watch in the U.S. at least.
That will be cool. All right, guys. Yeah, so I have... we talked about this, I think, while you were out, Harley, but here's the launch windows, the kind of trajectory, when it's going to land, 2-month deployment phase after it does land, and then it'll be there for 2 years, 1 Mars year, to do its business. But as we pointed out in this Hangout, that won't necessarily be the end of it. If it's still working, they'll keep it going and taking data. So that's really cool. So, okay. Well, let's see. I think we've covered most of what I wanted to ask. Did you have anything, Harley? I mean, I'm gonna, while you're asking, I'm going to look at the chat. So go ahead.
Yeah. So actually, so back in history, and again, I don't know, again, Emily and Johnny, if you're involved in this project, it has been several years since it was selected. Is that not correct? Do I remember 7 or 8 years?
That's true. I think we were selected in 2010.
Yeah, and once again, and share this because of the audience you got. I think it's worth sharing with these folks that these missions are a major engineering, technology, operations management challenge, and there were some hurdles early on, hiccups early on in the history of the mission. I don't remember the presentation, but maybe the two of you were there and can describe some of the challenges that you faced in pulling this thing together.
So basically, our seismometer had some issues early on. So it's actually, we call it a seismometer, but it's actually comprised of 6 seismometers measuring different axes and various frequency of waves, and 3 of those have to be inside an evacuated sphere, so it has to be complete vacuum. In the early design, that vacuum wasn't maintainable, so that actually caused us to slip our original launch date, which was 2 years ago. So now we got that all fixed. We have redesigned that part. And we have a completely working seismometer now. So now we can launch this year, and all our testing is very good, and we're pretty much just waiting to launch now. We're ready to go.
That's great.
Good point. Excellent opportunity to remind the audience that the launch windows are, in this case, like a month long, but they, if you miss them, you wait 26 months.
Yep.
For the relative orientation of Earth and Mars to come back around again for this type of trajectory. So there is a lot of pressure. The planets put a lot of pressure on our Mars colleagues to get the missions successfully built and ready for launch, because it's very painful for individuals, the engineers and the scientists and the managers, to wait more than 2 years before the windows open up again.
That's a good point. Okay, Larry Keese is commenting, Tony, can we have a live hangout for the landing? Sure. You mean like I set it up and rebroadcast and we all sit around and watch it together? I think we could do that. Did you say it was the day after Thanksgiving, Emily?
It's the Monday after Thanksgiving.
The Monday after Thanksgiving. Good. I'll be, you know how holidays are, right? So I couldn't promise that. But yeah, let's do it, man. I'll set it up and we can all watch it together and comment and have fun. That'll be a good idea. That's a good idea.
Yeah. Well, and again, to personalize this a bit, Johnny and Emily, what will the two of you be? Will you be spectators, or do you have a role during the landing?
So we both have roles. Emily and I will both be on the surface operations team. So I'll be in the room helping to lead all the initial downlink analysis as we get all the first data, first pictures and everything. And Emily can talk about what you'll be doing.
Sure. So primarily I'll be working with APSS. So once we're on the surface and ready to start operations of the instrument, I will be writing the commands that will be sent to operate the APSS instrument. So that's our wind and temperature sensors again, our pressure sensor, our magnetometer, and then also be responsible for looking at the data that comes down and assessing the health of those instruments.
And that will be at JPL.
Yes.
Awesome. My job, official popcorn. I'll bring the popcorn, guys. Okay. Achilles 308. Will the images be time restricted or are they open? That's the data coming back. You guys are going to be like embargo on this stuff, or is it open and ready, available to most people? I realize these aren't exactly images, but.
So what I've heard is that all the data should be available within about 3 months after we take it, but images may come earlier. Johnny might know.
Yeah, especially the first images we take, it should be, I mean, the whole world will see them the same time we do, pretty much. Mm-hmm. And then later images, especially when we do mosaics of things, we take lots of pictures to get a full view of landscape and of ourselves. We take selfies. Those will take a little bit longer.
Okay, I got to read this one. One plot. This is a hilarious question. Okay, so what will you consider? What will you consider a minimum level of success for the mission? What do you least want to learn? So basically, when you've learned it, okay, we learned the thing we care the least about. We don't care crap about this, so we learned it. We're done. Yeah. What
Oh no!
I'm sorry. I just thought that hit me funny. What would be your levels of success for the mission itself? What would make you say, you know what, this was a great mission. We got what we wanted. Any benchmarks?
Yeah, so we have two overarching goals, and one, we want to understand the formation and evolution of terrestrial planets, and the other one is we want to understand the tectonic activity on Mars, if there's any there, and also hopefully measure meteorite activity on Mars. So those are kind of our two overarching goals. So that's what we'll be working towards. And so there's a lot of different measurements that will go into that. So we want to try and determine thickness of the crust, composition of the mantle, which is one of the inner layers of Mars, what the core is like. And so all the steps that we can take along being able to answer those questions will help us get to really understanding those two overarching goals that we have for InSight.
Okay, Hans Milling, I'm going to ask your question, but first I have to explain it to our guests a little bit. So everybody here in Deep Astronomy Land, guys, we're a little bit raw right now because we just learned that the James Webb Space Telescope is delayed won't be out for another 2 years. So we're a little bit sensitive to this. And so Hans Milling is asking, is anything that could delay the launch, like JWST? You guys are basically ready, right? I mean, it's all ready to go.
Our rocket's on the pad, the lander goes to pad and to be mated to the rocket in just a week or two. So,
okay.
Yeah, we're ready to go.
Yeah, all the engineering activities are done from our side. So it's just a matter of the launch team.
So no delays like what they run across with that, because those were testing and delays, and those were delays that they weren't expecting. Alexander Rangers, real quick, and then we got to go. Is there a kind of GPS on Mars without a magnetic field? That's not how GPSs work, Alexander. They work from triangulation of the satellites, don't they? They don't need magnetic fields.
Well, it's not really triangulation, although that is a challenge, is it not? Once again, Emily and Johnny, to determine exactly where you've landed. Now that, of course, we'll have an imager, you'll have a high approximation, but not within, when you first touch down, not within a few miles. The landing ellipse is pretty big. And so then you take a look around and you have, I forgot which is it Odyssey that has the high resolution.
Mars Reconnaissance Orbiter.
Yeah.
Yeah.
And they look for you.
Yep.
I think that's how they determine exactly where you are. It's, the eye in the sky looks for you and then tells the world where you're located.
Yep. Okay, well, that is it for... Oh, I think that earthquake was... Larry Keys is saying it was a 5.3.
Wow.
Oh. Ooh, look at Emily. Ooh.
My desk did shake for a little bit, so...
Yeah, okay. Yeah, so now it's a little bit... Now it's not so easy to sit through, is it?
Yeah, this is the kind of experience you'll have to tell your InSight. This is the kind of experience you have when you come on Future in Space.
Yep, that's right. Okay, well, Harley, we got it. I think this is only our second one for the year, but we are back on track now with our Future in Space Hangout. So you want to talk a little bit about what we're doing in a couple weeks?
Oh, yes. It's the Parker Solar Probe.
Yep.
We're going to touch the sun. And this is one of the most ambitious, it is the most ambitious solar probe that has ever been launched, named after Eugene Parker, sort of a professor I had in graduate school.
Yeah, I met him once myself. Yeah.
So, in any case, so it's Parker Solar Probe touching the sun 2 weeks from today.
Yes. Okay. Thank you, guys, and thank you also. I want to thank our guests, Johnny Grinblat from the JPL, also Emily Manor-Chapman, also from JPL. These guys are going to be busy for the next few weeks, and we really, really appreciate you taking time out to talk to us because we are very excited with you, along with getting this mission up and onto Mars. So, Thanksgiving, we'll be thinking about you. I'll be up here. I'll be looking at the landing and eating popcorn, while you guys, I'm sure, won't be eating popcorn. So, so thank you for taking time out to share the details of the mission with us. We'll see you guys next week when Carol, Christian, and I will be doing an Astro Coffee Hangout. We don't have the topic yet, but we're working on it. And we'll see you guys next Thursday as well. And I think we also have an ExoLife Hangout on Wednesday, but I have to talk to Kevin, so I'm not sure. Anyway, thank you all so much for watching, and as always, keep looking up.
And again, the traditional thank you from
our gravitational wave rubber ducky. It's a good thing I didn't hit. Yes, I forgot to. God, we got to bring that up more, Harley. You got to remind me you have it. So yes, the gravitational wave. What do we name him? Floaty? No, we didn't. We got to call him something. Anyway, he rides the ponds of space-time, floating on the gravitational waves. Alrighty, guys. Thank you.